This is question number 23 of GATE 2017 Metallurgical Engineering. Schematic diagram shows rolling of a slab. P and Q are points on the surface of the workpiece near entrance and exit, respectively. With reference to the workpiece, which one of the following statement is true? Option A. Friction force is along rolling direction at both P and Q. Option B. Frictional force is opposite to rolling direction at both P and Q. Option C. Frictional force is along rolling direction at P and opposite to rolling direction at Q. And option D is frictional force is opposite to rolling direction at P and along the rolling direction at Q. So to know more about such situations and problem related to rolling, you can refer lecture number 13 on analysis of rolling load calculations from the course Principle of Metal Forming Technology by Professor Pradeep K. Jha from IIT Roorkee. So before answering this, let's first understand some of the basics of rolling, and then we will come to the direction of frictional forces acting on the slab. So here I've taken the same diagram. So basically these are two rolls, and this is our slab which is passing through these two rolls. And let's say the initial height of this slab is h0, and after rolling the final height is hf, right? Similarly, the velocity with which the slab is entering is, let's say, v0, and the velocity with which it is exiting is vf, right? And this, let's say this point is p, and here also you can say it is a p dash. Similarly, this is q dash. So p dash is the point where the slab is entering, and q dash is the point where the slab is basically exiting, right? Now in rolling, what we assume is the slab which is passing through the rolls. So even after rolling, the width of the slab is not going to change. So the assumption is width is constant throughout the process, right? So the width, let's say the width of roll is b. So here also the width will be b, and after rolling also the width will be b only. So now if you do the volume conservation, so from the volume conservation, at any moment if you conserve the volume, so what will happen is, so b v0 h0 will be equal to b v h at any moment will be equal to b vf hf, right? So this is always going to be true for the process. Now since the width of the slab is constant, and we know that the value of h0 is greater than hf, right? The initial height of our slab is more than the final height or thickness, you can say thickness of slab initially and later on is hf. So h0 is more than hf. So from this what we can conclude is, since b is constant, so we can say is v0 must be less than vf, that is the final velocity of the slab which is exiting from the roll mill is having more than the entrance velocity. So this is the conclusion that we can draw. So which means from entrance to exit the velocity is keep on increasing. So we can say velocity is increasing steadily from entrance to exit. Now we know that this roll is also having some velocity, right? This roll is rolling with some velocity, let's say v, right? So both the rolls are rolling with the velocity v. So there will be a moment where the surface velocity of roll somewhere, let's say it is here, will be equal to the velocity of the slab or sheet which you are passing. So at that point, velocity of both roll and our slab or sheet which is passing will be equal, and that point is basically known as neutral point. So at neutral point, so if you want to define neutral point, so neutral point is what? Surface velocity of roll equal to velocity of sheet, right? So at this point, surface velocity of roll and sheet velocity will be equal. Now basically if you consider the force balance, right? So at any point, what are the like forces which is acting? So basically let's say this is the point which I am considering. So there will be a normal force. That force is given by Fn, and there will be a tangential force, right, given by Ft. So this normal force is exerted by this roll, and this tangential force, from where it is coming? This is nothing but our frictional force, right? And we know that the friction, the direction of friction force will be determined by the relative velocity, right? We can write it, okay, friction opposes the relative motion, right? We know कि friction opposes the relative motion. So till neutral point, velocity of roll will be more than the velocity of sheet, right? And at neutral point it will be equal to the velocity of sheet, and after neutral point the sheet velocity will be more than the roll velocity. So due to this, the direction of frictional force, so basically friction force will assist the sheet to enter into the gap till neutral point, which means friction force will be in the roll direction till neutral point, and friction force will be in the opposite direction of the rolling after neutral point. So this is the conclusion. Till neutral point, like till here, from this point to this point, friction will be assisting the seat to draw inside the rolls, and after neutral point, friction will be acting in opposite direction, and it will resist the sheet in this direction, like the friction force will be acting in this direction after this point, and before this point friction will be acting in this direction. So this is the conclusion we can draw. Now coming back to the problem where it is asking frictional force, so we can say is key friction force is along the rolling direction at P, which is like point of entrance, and opposite to the rolling direction at Q, which is exit point. So exit point lies to the right of neutral point and entrance point lies to the left of neutral point. So option C is a true statement considering the direction of frictional forces. The right answer is option C. Thank you.